All right, hey guys, this is the acceleration time graphs under constant acceleration. We don't have any acceleration time graphs in constant velocity in Unit 1, but Unit 2 we do. Now, the nice thing is these are pretty straightforward, but I still wanted to take a second to walk through them. So if I have a graph here, this is my A, okay, my T graph, my AT graph, and the unit typically is going to be meters per second squared. We'll talk a little bit about units here in a second. All right, so we're not having a change in acceleration in any of our problems, so we're not going to have any angles, we're not going to have any curves. The only thing we're going to see is a horizontal line. So if I have something that looks like this is telling me that I have constant velocity or constant acceleration that is 5 meters per second squared, okay, for however long, 2.5 seconds or so. Constant positive acceleration at 5 meters per second squared. All right, same thing. This should look kind of similar to kind of how VT graphs with constant velocity looked. All right, so now if I'm on here, this tells me I have no acceleration, which would say I am at constant velocity. If my acceleration time graph is right there on the 0 meters per second squared, meaning no acceleration whatsoever. Now, if I go below here, same type of thing. Now this is saying I have acceleration. It is on the negative side, so it's going in the negative direction. Again, positive, negative just tells me direction, tells me nothing more. So this is in the negative direction at 5 meters per second squared. So the acceleration is at negative 5 meters per second squared. That's all you're going to see. And they can mix and match these, and etc. You don't need to connect them. We don't need an angled line. We're assuming it happens instantaneously, which does not happen in real life, but for simplicity's sake, that's how we kind of interpret them at this stage in our physics life. So only going to be horizontal lines. This tells me it's positive acceleration. This tells me there's no acceleration. This tells me there's negative acceleration. Now, let's take one quick second here and let's talk units. Typically, we're going to see meters per second squared. This is the same thing as saying meters per second. So you may see it either way, all right? They're the same thing. Now, what we have to do is interpret this. So what I like to do, all right, is if we had to say this verbally, this extra second here tells me that for every second, all right, that's what that one tells me, the velocity, all right, now this corresponds with this part, the velocity is changing by whatever it is, it was x meters per second. All right? So this is really important. One, being able to verbalize what acceleration is. We know that the equation is change in velocity over time. But I want to be able to also, when I see a number, not say it has an acceleration of 5 meters per second squared, and not really know what the squared part means. All right? What it means is that for every second that passes, clock's ticking, 1 second, 2 seconds, 3 seconds. For every second that is going by, the velocity is changing by whatever that number would be. If it was 5 meters per second, it'd be 5 meters per second. If it was 10, it'd be 10. Doesn't matter. It's changing. Now, I'm not saying is increasing by, unless I know that with certainty. I'm saying changing, because that I can guarantee for any acceleration number, that's the truth. It is changing by however much. It can be a positive number or a negative number. But as we've seen, if you've watched the other videos about these graphs, positive, negative doesn't tell me if I'm getting faster or slower necessarily. It tells me the direction that acceleration is acting. And based on what the velocity already is, if it's a positive velocity and I have a positive acceleration, signs are the same, it's moving in the same direction, it's going to get faster and faster and faster. So let's say I have a positive velocity and then a negative acceleration. That change of velocity is going to cause it to get slower and slower and slower. Opposite signs slows down. So it depends. So that's why we can't really say it's speeding up or slowing down if it's a positive or negative number. We can simply say it is changing, the velocity is changing by 5 meters per second, negative 5 meters per second, negative 2 meters per second, positive 100 meters per second, whatever it is. All right, so for every second that passes, that velocity is changing by this amount. That's what acceleration means. That's what these units mean. All right, so just to clarify that, AT graphs, pretty straightforward. If there's constant velocity, you just write it in as 0 meters per second because there is no acceleration. All right, hopefully that helps a little bit.